This is how to wire a Victron SmartShunt, the little battery monitor that finally tells you the truth about your battery. Here is the finished wiring. The shunt sits in the negative line, battery minus on one stud, everything else on the other, and one thin sense wire up to the positive. Get that layout right, and it counts every amp in and out. Get it wrong, and the numbers lie. Let me show you exactly how it goes together. Before single wire, learn the one rule that makes a shunt work. The golden rule. The SmartShunt is a precision resistor. It measures current by reading the tiny voltage across itself, so all the current has to pass through it. Every amp your battery gives, and every amp it takes back, must go through the shunt. Nothing else. So here is the rule. The shunt goes in the negative line, and nothing connects directly to the battery negative except the shunt. Not a load, not the inverter, not the charger, not a chassis ground, only the shunt. Break that rule. Bolt one load straight onto the battery negative, and that load's current never gets counted. The shunt sees less than the battery really gives, and your state of charge drifts wrong within a day. One negative post, one wire off it, straight to the shunt. That is the whole trick. Quick note before we wire it. Everything I draw is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. Now the shunt itself. It has two big studs, and getting these two right is 90% of the job. One stud is marked battery minus. That one bolts to the battery negative post, and only the battery negative post. A single fat cable battery to shunt, nothing else on it. The other stud is marked minus to system or load minus. This is the common point for everything else. Every other negative in the system lands here. The inverter negative, the charger, the solar controller, the DC-DC, the fuse block, the chassis ground. All of them onto the system stud. See what that does? The only path from any load back to the battery runs through the shunt, stud to stud. So every amp is measured. Battery side to the battery. System side to the world. Never swap them. Now the small red wire. The shunt needs power for its own electronics, and it needs to read your battery voltage, and it gets both from one thin wire. That is the B+ sense wire. It runs from a terminal on the shunt straight to the battery positive. Low current, so it is a thin wire, but it must have its own inline fuse right at the positive end. A 1 amp fuse is typical. That fuse is not optional. It is a live wire on your battery positive, and if it chafes through, you want it to blow, not burn. With B+ connected, the shunt wakes up, powers its Bluetooth, and now reads the full pack voltage, negative through its own body, positive through the sense wire. Volts, amps, and everything the app calculates from them. There is no display on a SmartShunt. It talks over Bluetooth, straight to the VictronConnect app on your phone. Open the app, pair it once, and you get the real numbers. State of charge as a clean percentage. Amps flowing right now, positive when charging, negative when you are pulling. Amp hours consumed, and time remaining at the current draw. One setup step matters. Tell the app your battery capacity, the amp hour rating, and whether it is lead acid or lithium. The shunt counts the coulombs. You give it the size of the bucket. Get that number right, and the percentage is trustworthy. Now, the mistakes, because almost every wrong reading comes from one of these four. 1. A load on the battery negative. The big one. Any negative bolted straight to the battery post instead of the system stud is invisible current. The shunt never sees it, and your state of charge slowly lies. 2. The stud swapped. Battery cable on the system stud, loads on the battery stud. It still passes power, so it looks fine, but the sign of the current flips and the counting goes backwards. 3. No fuse on the sense wire. A bare positive wire across your battery with no protection. One rub through and is a dead short. Always fuse it at the positive. 4. An undersized shunt. A 500 amp shunt behind a 3000 watt inverter that pulls near 300 amps is fine, but push a shunt past its rating and it heats and drifts. Match the shunt to your peak system current. So size it and land it properly. Pick the shunt for your worst case current. Add up your biggest simultaneous loads, the inverter surge, the DC-DC, everything at once. SmartShunt come in 500, 1000, and 2000 amp versions. Choose the one that clears your peak with margin. Then the mechanics. The two big studs carry all your battery current, so they have to be tight. Torque them to spec, clean and flat, no washers stacking up loose. A loose shunt stud gets hot and reads wrong. The thin B+ wire only carries milliamps, so it is easy, just fuse it. One shunt, two fat studs, one to the battery and one to everything else. One fuse sense wire to the positive. That is a complete, honest battery monitor. Here is a real solar and battery system, open straight in the editor. Solar panel, charge controller, a 12-volt battery, a fuse, and a load, with a negative return running along the bottom. And this is exactly where SmartShunt installs. You cut into that negative line, right at the battery, so the battery minus lands on one stud and the whole system negative on the other. Follow any wire, end to end. That is what a clean drawing gives you before you ever pick up a spanner. Now, let us lay one out from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A battery, a block standing in for the shunt, a load for the inverter, and a ground. These come from the free do-it-yourself pack the guest editor gives you. There is no dedicated Victron symbol here, but these shapes are enough to lay out the negative line idea and hand it to whoever does the install. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. And here is something a plain drawing tool cannot do. Simulate it. I will open a ready-made circuit with a real battery and a load. There is a genuine SPICE engine inside the page. Hit Simulate. Choose the DC operating point and run it. Live voltages and currents land right on the wires. You can watch which way the current actually flows through the negative path, the exact thing the shunt is there to measure. A check no paper drawing can give you. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a build thread or a group chat with whoever is helping with the van. Vector formats, PDF, SVG, and DXF sit on the paid plans. That is the honest business model, and I will say it plainly. This tool is ours. For clean battery and solar wiring you can share and mark up, it is genuinely good and free to start. One last thing. If your build has any control logic, a battery protect, an automatic transfer, or a relay that sheds loads on low voltage, that is a different kind of drawing. For building and running logic like that, scan by scan, our sister PLC simulator does exactly that, and it is linked in the description. Draw the wiring here. Run the logic there. So that is a Victron SmartShunt, start to finish. The shunt goes in the negative line. Battery minus on the battery stud, and only the battery. Everything else on the system stud. A fuse sense wire to the positive. Nothing but the shunt on the battery negative, so every amp is counted. Open the free editor and lay out your own battery monitor, a battery, the shunt, a load, a ground. It is at CircuitDiagramMaker.app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.